Hi, this is Tarik Rashid. Today we talk about support vector machine and we talk about the implementation of support vector machine when we encounter linear problems. So if we um, if we have this problem, positive classes, 1, 2, 1 and 2, that point, and another point, 3, 1, which is this point. 3, 1. So this point. And we have negative classes -1, -2, -1 would be that one, -2. And this is the y-axis for it, -1, -2. And we have -3, 1. -3, that means that's -3, -1. So we try to get the support vector, which is this one, very close, which is 1, 2, and this one, -1, -2. So these are the support vectors that are very close, and we can take more points, but these two is fine for this problem. So the support vector S1, -1, -2 for the negative, and positive support vectors, as we said, 1, 2 for the positive. Now we try to uh, convert these support vectors into augmented vectors by adding bias 1 to each support vector. So I added 1 here and we added 1 here. And now we try to create an equation 1 for the alpha because sigma sigma equal we try to create an equation whereby W equals sigma alpha I support vector I. So for first one, alpha 1 support vector 1 multiplied by support vector 1 plus alpha 2 support vector 2 multiplied by support vector 1 plus alpha 3 support vector 3 multiplied by support vector 1 plus alpha 4 support vector 4 multiplied by support vector 1, and so on and so forth for the class 1. This is the results. So 1 multiplied by 1, 2 multiplied by 2, 1 multiplied by 1 for the first one. And this is the second one multiplied by -1, 1 for the support vector 2 multiplied by -1, and 2 multiplied for support vector 2 multiplied by -1. So that's the equation found. Likewise, we will do the second equation, alpha 1 support vector 1 support vector 2 plus alpha 2 support vector 2 multiplied by support vector 2 plus alpha 3 support vector 3 multiplied by support vector 2 plus alpha 4 support vector 4 multiplied by support vector 2. So that's the two equations, and we try to solve them. The first equation sorted out, alpha equals 1 -1 over 10, and for the second alpha, 1 over 10. Now we try to get the W, which is, as we say, sigma alpha support vector machines. So alpha 1, we have it 1 over 10 multiplied by -1, 1 over 10, -1 over 10 multiplied by -2, 2 over 10, -1 over 10 multiplied by 1, -1 over 10, and likewise 1 over 10 multiplied by 1 for alpha 2 support vector 2, 1 over 10 multiplied by 1, 1 over 10, 1 over 10 multiplied by 2, 2 over 10, 1 over 10 multiplied by 1, 1 over 10. Now add all these, 1 over 10 plus 1 over 10, 2 over 10, 2 over 10 plus 2 over 10, 4 over 10, minus 1 over 10 plus 1 over 10, it will be 0. So that is that's our uh, weight vector or weight vector, which is 1 over 5, 2 over 5 is 0. Now, for this, the line, I mean, um, our slope is half because if we multiply by 5, 1 over 5, x1 plus 2 over 5 x2 plus 0. If we multiply by 5, it'll be 1 x1, 2 x2, and 0. So x2 equals minus 1 over 2. That's the slope. We found it. W1 over W2, that's the slope. And we have B0, that means the bias, 0, that means the line can go through the origin to separate the two classes. And if we plot it in this way, these are the classes of red. This is a support vector, this is support vector, and the line goes through origin because the B was 0. That was the idea how we manage. And this is the slope, which is minus 1, 2. So that is the idea of how we manage to work with support vectors. If we try to do a testing for this, if we have a testing data and we just plug them into this equation and we see if it is greater than 0, that would be positive. If it is negative than 0, if it's smaller than 0, that would be negative. So let's take some example. For example, we have 0.44, plug into 1x1 plus 2x2, 4 plus 2x2, 2 multiplied by x2, which is 4, 4, 8 plus 8, 12. So this is greater than 0, that's a positive point. And if we take a negative point for testing, negative 4, x1 plus 2x2, x1 negative 4 plus 2x2, 2 multiplied by negative 4. So that's negative. That is less than 0. It means it's a class negative. So that's the plot for them, and that's the W, how we found it. And hopefully it was useful and simple.